Hey everyone, it's Mr. Canfield. Today we're going to do Pythagorean theorem in quadrilaterals practice. Woo. Okay, so just a reminder, anytime we have a right triangle, we can use the Pythagorean theorem, a squared plus b squared equals c squared. And remember that c squared is always that c is the hypotenuse, and we're going to square it, and the a and b are always the legs. So let's go through. There's a couple of kind of warm-up questions into this, and then we'll be doing the practice. So ABCD is a square. Mark all the right angles in the figure. How many are there? So since this is a square, we know we have 4 right angles in the 4 corners. And then the middle. Since this is also a rhombus, remember a square is a special kind of rhombus, then we're guaranteed that these are also right angles in the middle. So you can just mark it as the one, or because if you mark that one, they all have to be, or you can do this if you like doing that. But there are a total of 8 right angles in this figure. I think an additional question that might be interesting to ask is how many triangles are in this figure? Because I agree there's 1, 2, 3, 4, but is that it? And then you could, if you think a little bit more about this, how about that one? There's 1. And then if we mirror it, and you got the one down here, that's 2. So there's actually 6 triangles. Oh, wait. So we did this one and this one. What if we do this one and its mirror, this one? So there are actually 8 triangles hidden in these. And on the other ones too, we're gonna have 8 triangles. Specifically, these are 8 right triangles in this one. You've got tons of right triangles. Let's move on to just a general rectangle. Let's do the same kind of investigation. So we got these 4 right angles. In a rectangle, you're not guaranteed the middle is right angles. So that's important. And then on top of that, since these aren't right angles, this is not a right triangle here. This is just an isosceles triangle. And that's the kind of thing where this angle and this angle are equal, and this side are equal. Like that's the kind of thing that's happening there. And so you have these 2 little isosceles sets. Like there's the isosceles, and these are the same isosceles. These are the same. So if we want to just find the right triangles this time, this won't be a right triangle, but this is a right triangle. And so we'll have this in its mirror, like the other half up here, and then we'll have the other kind that goes over on this side. So we've got some of the right triangles we had before, but not all of them. And then next we have a rhombus. I'm actually gonna go to number 4 first. So same exercise, just in a general rhombus now. In a general rhombus, you're not guaranteed these are right angles. You're guaranteed all the sides are the same, but you are guaranteed that you have the 4 right angles in the middle. And so with a rhombus, you have this right triangle, this right triangle, this right triangle, this right triangle. So you just have those 4. If we look at the bigger triangles this time, like that, you don't have any right angles guaranteed in that, so we don't have the right triangles guaranteed by the bigger shape. So now we can go back and talk about this. In rhombus, ADB, why? Why don't you just do ABCD? AB is 20. Okay, so let's see. A to B is 20. Wait. A to B, this is 20. Well, it's a rhombus. It's a parallelogram. These diagonals are cut in half. So if the whole thing is 20, then this has to be half and half. So half of 20 is 10. So 10 and 10. Similarly, ED is 8. So it says ED is 8. It doesn't say the whole thing. It says just from E to D. Well, that means that's 8, so that's 8, because it's cut in half again. So it says find AC, round to the nearest tenth. So we want to find that. Wait, look, it's a rhombus. We know a squared plus b squared equals c squared, because it's a right triangle. So A is one of the legs, either 10 or 8. It doesn't matter which one you pick. I'll pick 8. 8 squared plus 10 squared is equal to c squared. And so you can either figure these out. 8 squared is 64, 100 squared is, 10 squared is 100, so you get 164, and that is c squared, and then take the square root of it. But if you want to use your calculator, first you got to drop everything on the floor. Yeah, sorry about that. So I'll do 8. Remember, that gets you squared. You can do 8 squared plus 10 squared. Like, you can just do it in one step if you want. Boom. I got 164. And then we'll take the square root, which on my calculator is it's that blue color, so I got to click the blue button. I got to click second, square root, and then I'll type in 164, and I get 12.8 is approximately C. I guess in this case it's AC, but we called it C in this, so we're good. Okay, let's make sure we know how to round this. Am I supposed to take this and round it up to 9, or leave it, or round it down to 7? You never round it down, just a heads up. You only ever leave it where it is, or you get to round it up. And the way you round is you look at the decimal place after, and you say, is that enough to push me over to the next number? So if it's 5 or more, it's enough to push you over to the next number. So if that was 12.85, we would round this up to 12.9. If it was 12.84, we would not. So, and then I'm going to talk about advanced. So if you want to skip this, but I want to make sure I mention the advanced portion of this, the square root of 164. We want to see if this is simplifiable at all. And yeah, it is. Okay, so basically what I want to do is break this down and see if there are any perfect squares that go into 64. Perfect squares are things like, well, 2 squared is 4, so 4 is a perfect square, or 5 squared is 25. 25 is a perfect square. So since you are doing the advanced method with me, I'm not going to go through that completely, how that works, but I know 4 goes into this. I just double checked. It's 4 times 41, and 41 I can't break down anymore, so I could rewrite this as the square root of 4 times the square root of 41. And the square root of 4 is 2. So this is 2 root 41. And this is what we call a simplified radical. And after I finish the rest of the video, I'm going to go back and simplify every radical we get for anybody who's interested. You know your own trajectory. You might need this in the future if you're going into math or science. And let me use another packet, since who knew that writing in marker would bleed over. All right, so advanced work is done. Here we go. Here's number 5. Find the measure of angle 1. All right. Oh, well, I know this is a right angle right here, and that's 28. So couldn't I do 90 minus 28, and that'll give me that piece there? 90 minus 28, 62. Okay, I got this as 62. And remember we talked about this earlier. This is an isosceles triangle here. This and this are the same. So that's 62. That means this is 62. And that's 28. This is 28. It says find the measure of angle 2. 28, 28. Oh, so if I want to find this one, I know 28 and 28 because it's another isosceles triangle. Well, then I can do 180 minus 28 minus 28, 124. So angle 2 is 124. Those of you who took my test recently quiz, it was a quiz, might recognize this from that quiz. Might be the exact same question. All right, so then it says, so let's see, angle 1 was 62, angle 2 was 124. Now it says find AB. So find AB. I know 8. I need to find a right triangle here somewhere. Hey, look. We know AC is 17. So let's pull this out. 8, 17, and then this is our unknown. You can call it X if you want. You can call it A, B, whatever. It's not C though, because that right angle always points to C. So 17 is C. So I can't go 8 squared plus 17 squared equals X squared, because 17 is the hypotenuse. I have to say X squared plus 8 squared, excuse me, or 8 squared plus X squared. These are A and B. And that is going to equal 17 squared. So it doesn't matter which one of these you do, you're going to have to subtract that 8 squared from both sides. So well, let's figure out what these numbers are. So 8 squared is what? 64. 17 squared, I think it's 289 if I remember. Yeah, 289. It's not magic. I've just seen it enough that I memorized it. So this is 64 plus X squared is equal to 289. So we want to get X by itself. So we'll just subtract the 64 from both sides. So 289 minus 64. I got 225, so X squared is 225, and so the way we finish that is we take the square root of both sides. The square root of 225 is 15. There's no advanced method for this one since the exact answer is 15. That's 15 there. Okay. This says find the area of ABCD. Well, the area of a rectangle is length times width, where base times height. In either case, 15 is one of those, 8's the other one. 15 times 8 is the area. 120. And since it's in inches, we could say it's 120 inches squared, since we're talking about area. Earlier when we were talking about X, we could say that is 15 inches. Okay, onward. Oh wait, oh yeah, I have the 2 packets. You know, this will work, because then I'll write on this page and then I'll write on the next page. Okay. Fish, almost, is a square. HI is 5. Okay. Find the measure of angle 1. So this is similar to our rectangle a couple minutes ago. We're guaranteed these are isosceles triangles, and so all these are going to be the same because it's a rectangle. Well, that's 45, so then that's 45. So to find this, well, it's a square. If you remember from earlier, this has to be a right angle. And this is actually a special kind of right triangle that we have here, called a 45, 45, 90. It's one of our special right triangles. But wait, so if that's 5, we know this is, we know all these are 5, right? Because it's a square, everything's equal. So find the measure of angle 1. I was getting ahead of myself. Angle 1 was 90. Angle 2, well, these are all 45s. Yeah, 45. So 90, 45. Find FH. Boom, boom. Hey, look. If I want this, that's the side of a right triangle that I have. I have this right triangle. So I'll do this right triangle of 5, 5, and that's my right angle. So it points to my, that's C. Let's say 5 squared plus 5 squared is equal to C squared. So 5 and 5 squared, those are 25 each. 25 plus 25 is equal to 50. Now, if you said 10, if you said 5 squared is 10, that's so normal. Don't feel dumb if you said 5 squared is 10. You just weren't thinking hard enough about it. 5 squared is 5 times 5, not 5 times 2. So when we take this square root, we're going to get some yucky decimal. This is a simplifiable square root. We'll come back to it and talk about it later. So square root of 50 is 7.07. Okay. How do I round 7.0710678812? Well, I want to round to 1 decimal place, right? So what does the number after tell me? 7 is big, so it tells me move up. 7's 5 or more, so it says move up. So instead of 7.0, it's 7.1 is what we get. And I like to use the squigglies for approximately to show that this is not exactly the answer, it's about the answer. So that's FH. Then it says find the perimeter of fish. Well, if we know all the sides are 5, 5 plus 5 plus 5, that's 20. So 7.1 inches, all right. we're dealing with a length, it'll just be the regular unit. When we're dealing with an area, it's the unit squared. Rella. I don't even know what words we're trying to spell anymore. It's a rectangle, and it says RL is 11. Okay, that's 4. So angle 1, angle 2. This, I mean, it's more of the same. It's a rectangle, so we know all 4 of these are equal to each other. So at 22, 22. I can find the other counterpart here by doing, it's a 90-degree angle, right? So 90 minus 22, you get 88. So you got 88, and then, so it's an isosceles triangle. So this angle and this angle are the same. So 88, 88, 22, 22, 88, 88, 88, 88. All right, cool. Oh, it doesn't even answer everything. Angle 1 was 22. I wasn't really even paying attention to what it was asking for. I just was filling in things I knew. Don't be fooled. I wrote 11 right there. That angle's not 11. That whole side was 11. So you can throw yourself off if you're not paying attention to what your markings mean. But if I want to find angle 2, I got this triangle down here. So I could do 180 minus 22. No, not 2, 2, 2, 2. Minus 22, minus 22. So I got 136 right here. All right, find LA. It's in California. No, all right, so find LA. That's this guy down here. Let's see. I have this, and I need to build a right triangle. Oh. Wait, I know RL is 11. Oh, this is also 11 then. If I do that, I know that's 11. Wait, that's 4. It's a rectangle. So that's 4. There's my right triangle. So this is another situation where we know a leg and the hypotenuse. A little shortcut is you're always just going to subtract when you do these. So I could do 11 squared minus 4 squared, and that's going to be my third side. You can call it B or whatever you want. So 11 squared, whoops, let's try that again. 11 squared minus 4 squared. I got 105. So then we'll take the square root of it, 10.246, so 10.2. So a nitty-gritty question that comes up sometimes is people will say, well, wait, I could round that 4 up to a 5, and then using that, I could round that up to a 3. And the reason we don't recommend that is whenever you round, you're saying it's basically here. So we don't want to say it's basically here, so it's basically here. With argumentation like that, it's possible to say things that are really false. Just by kind of you're like bending the rules a little bit. But if you bend the rules at each step, then you're gonna be way off the target. So we say round once. If you want to say 10.25, you could. You would stop there. You wouldn't continue rounding. Okay. So 105. I don't think it's simplifiable, but we'll look at that when we look at the simplifies. All right, then we're on to number 8. Number 8. Lion. Rawr. Scary lion. Lion. All right. NO is equal to 4. All right, let's see. NO, 4. Okay. Find the measure of angle 1. Well, it's a rectangle, so that's a right angle right here. 27 and 1, let's do, okay. 90, sorry, that was loud. 90 minus 1, okay, so this is 63, right? And they're isosceles triangles, so 27, 27, 63, 63, 27, 27, 63, 63. All right, so angle 1 is 63, angle 2, oh, the one in the middle. Oh, well, I got this triangle here. So I could do 180 minus 63 minus 63 and get 54. So that's 54. Find LO. L-O. Wait. L-O. I know NI is 9. That's interesting. NI is 9. That means from here to here is 9. That means that each of these pieces is half of that. 4.5. So 4.5, 4.5. And since this is a rectangle, 4.5, 4.5. So if I want to find LO, oh, LO is also 9. I did way too much work. If I know the whole diagonal here is 9, it's the same diagonal. I didn't need to break it all up in half and stuff. 9, okay. Find the perimeters of LON. Perimeters? Perimeters, there's just one. LON. Okay, so we got 4. I know this is 9. I just need this side. Well, let's look at that. That's a right angle. 9, 4. Oh, Pythagorean theorem. 9 is our hypotenuse, so I'll need to do 9 squared minus 4 squared. I get 65 is equal to b squared, or a squared, whatever you want to write there. Take the square root. Excuse me. And I got 8.06, which is 8.1 when we round it. Cool. I'm trying to keep this brief, so I'm just going to keep on going. Hopefully it's helpful. And if you're like, this practice is repetitive, yeah, that's what practice is. That's what it's supposed to be. You practice it so it becomes easier for you. Random person who probably doesn't actually have that question in their head right now. You listening probably aren't like, why is he doing all the problems? I don't want help. That's probably not you. All right. So it's a square. Oh, it's a square. So we already know these are all right angles. Oh, angle 2. So angle 2 is a 90-degree angle. And angle 1, since it's a square, everything's cut up evenly, so that's a 45-degree angle. These are all 45s, so 45. Now it wants us to find OF. Oh, it says WO is 6. WO is 6. So it's a square, so all these are 6s. I want to find OF. Oh, there's a right triangle. So 6, 6. And that's across from the right angle, so it's C. So 6 squared plus 6 squared is equal to C squared. 6 squared plus 6 squared is 72. I mean, I don't know what it is yet. I'm using my calculator to find it. 72. So we'll take the square root of it. This is another square root that will simplify. So we'll come back and talk about that later. So that's 8.48. So the 8 rounds the 4 up to a 5. So C is approximately 8.5. Now it wants the area of Wolf. Well, it's just length times width, or even it's a square, so you just say it's the side squared since length and width are the same. So 6 times 6 is 36. All right. Milan. MLON is a square. Find the measure of angle NMO. NMO. Oh, okay. Well, we know this whole thing is 90. And these are 45s, so it's a 45-degree angle because it's a square. Everything's perfectly cut up. Find the area of LMO. LMO. We have not talked about area of a triangle, but we did talk about the area of this square is just going to be 5 times 5. So the square, the squarea, the area of this square is equal to 5 times 5, which is 25. LMO, how much of this square is LMO? Well, it's half of it. So you just divide that by 2. Excuse me. 12.5. And secretly, that is how you find the area of any triangle. If you know its base and its height. All right, let's see. C, find the perimeter of LMO. Well, I know LMO, boom. I need this third side here. Oh, and this is a right angle. So I can use Pythagorean theorem. you travel back in time with me, you might remember we have literally already done a triangle with sides 5 and 5. We did 5 squared plus, so 7.1. Excuse me. Do all the work, there it is. Boom, done. So then 5 plus 7.1, since it asked for perimeter, 17.1. All right. Almost done is what I would say, but we have many more. Okay, so again, if it's helpful for me to go through them, here I am going through them. All right, let's see. Find the measure, let's see, we got a rectangle. Okay, so since it's a rectangle, I know we got right angles in the corners, and I know these are all equal. Okay, so 27, and the lights went out. All right, I had to run around in a circle to show my lights that I humans in here. Let's see, ACD. Oh, this angle right here. Well, those add up to 90, right? So we'll just, I should probably use the word. We call these complementary. You look lovely today, so do you. There, they complement each other. They equal 90. Okay. Find the sum of the lengths of the two diagonals. Fancy. It says AC is 13. Oh, what's the other diagonal? Oh, wait, it's the same, also 13. Excuse me. The sum of the lengths of the two diagonals. Well, what's one of the diagonals? 13. What's the other one? 13. Ooh. 26. Because the sum means add, and the two diagonals are the crisscross. Find the perimeter of ABCD. Okay, well, I know this is 13. Oh, that's 5. Oh. Okay, so we're going to use this to find that side, and then we'll know 5. We know this is 5 because it's a rectangle, and whatever that is, it'll be the same over here. So I can use Pythagorean theorem. We got 5, we got x, and then we know 13. So since our right angle's here pointing to 13, remember, when we set this up, 5 squared plus x squared is equal to 13 squared. We're gonna have to subtract. So a lot of people, when they see this, they're like, oh, well, I'm gonna skip this first step and just do 13 squared minus 5 squared. I do not have a problem with you doing that if you get why you're doing it. So 144, that's our x squared, so we'll take the square root of it, and we get 12. And because this worked out perfectly, let me remind you of a phrase or a term that we use for this. This is called a Pythagorean triple. The fact that you have the nice numbers 5, 12, and 13 together, it's something that a lot of people like to memorize because they show up frequently, because it's one of the few choices we have where we don't get yucky decimals as answers. So 5, 12, 13 is probably the second most famous one. The first most famous one is the 3, 4, 5. Oh, so perimeter of ABCD. Well, we got 12, we got 5, then we got 12, we got 5. So add them all up, right? 10 plus 24, 34. If I was doing a test, I would definitely do like 2 times 5 plus 2 times 12, or like 5 plus 5 plus 12 plus 12. I would show what I'm doing so that the 34 sitting here, if I made a silly mistake, I actually have something to back it up to prevent me losing more points. All right, CAM, C-A-M, it's a rectangle. CAM, it's a 90, okay, that was hard. Find the length of CM. It says KC is 8.5. Well, it's a rectangle, so these are all split up. So this is also 8.5. Oh, what's 8.5? 2 of them. Just add them together. It's 17. Now we want to find the perimeter of camp. Hey, funny we should talk about Pythagorean triples. This is another Pythagorean triple. I already know the answer. just because I have memorized, not because I'm special. So this is where I'll do what? 17 squared minus 15 squared. Oh, sorry, because 17 is the hypotenuse. We would add them otherwise. Take the square. I already know square root of 6. Yeah, good job, dum-dum. All right. 8. So if you're still watching at this point in the video, and if it's helpful, then that's great. I would imagine most people would have clicked off by now, but if you are still paying attention, just know that you are worth filming this for, and I hope that if it is helpful, I'm glad that I'm doing it then. Usually, we get to this point in the video, no one's still watching, so. But hey, I get paid either way because I'm doing this at work. All right, and if you did sit through all that and you heard all that, you should find me and tell me that the rain in Spain stays mainly on the plain. And I'll know what you mean. All right, so let's see. Camp is a rhombus. I told you a couple minutes ago, 3, 4, 5 is a famous one. If you don't believe me, well, now here's our chance, because we got a right triangle here. I can find that diagonal. 3 squared plus 4 squared is 25. We'll take the square root and we get 5. Since this is a rhombus, bam, 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 all the sides are equal. That's 3, that's 3, that's 4, that's 4. Let me read the question. Find BMA, that angle. BMA, oh, well, the angles get split up evenly too, so 18, 18. That's one of the big differences between a rectangle and a rhombus. In the rectangle, the corners are right angles, so these are rarely the same. In a rhombus, these are always the same. These will be a different number here, though. MBP, that's 90. And the perimeter of camp, well, 5, 5, 5, 5, 20. Okay, now we are almost done. And again, if you stuck through this whole thing with me and it's actually helpful, the rain in Spain stays mainly on the plain. And I'll know what you mean. Shed is a square. Is every shed a square? Because my shed at home is a rectangle. And it's a box, it's not just a flat image. All right, dumb joke. Let's see. HWE, well, it's a square, so we got right angles. Everything's right angles. HED, same kind of thing, right angles. Yep, so 90. Find the sum of the lengths of the diagonals to the nearest hundredth. So we need to find the sum of the lengths of the diagonals. That's this thingy and this thingy. Oh, wait, look. Look at that. We got a right triangle here. We know that's 6. It's a square, so everything's 6 out here. We did this exact problem earlier with a right triangle with a 6. We did this one earlier. All right, this is 6 squared plus 6 squared, 8.5. All right, so that piece there is 8.5. That's 8.5. Wait, if that's 8.5, that's also 8.5. What happens when you add them up? That's the sum of the lengths of the diagonal. 8.5 plus 8.5. 17. Whoa! That's old enough to go see a rated R movie in the movie theaters. If AE is 7. Actually, I don't even know if that rule still applies anymore. When I was your age, that's what it was. AE is 7. Find the side length of the square. Now this is, I like kind of how elegant this question is. It doesn't give us a whole lot, and so we have to kind of imply and figure everything out. But it's a square, so we know all these sides are equal. We know all these sides are equal. So 7, 7, 7, 7. Oh, okay, if I want to find the side length, well then I can just use this. Say 7 squared plus 7 squared. Oh, that's a right angle there, sorry. So it's equal to c squared, so that's 49 plus 49 is equal to c squared. So what is that, 98? 98 is equal to c squared. So I know that the square root of 100 is 10. So I know this is going to be close to 10 because this is close to 100. Square root of 98. Sure enough, 9.8 and a 9. So then the 9 tells us to take that 8 and round it up. So 9.9. And then find the angle ECD. It's another 45-degree angle because it's a 90 get cut in half. All right, our next one. FA is 10. Okay. Same question as before, right? If that's 10, well, these are all 10. If I want to find the side lengths of a square, you can just pick one of the four and do 10 squared plus 10 squared is equal to c squared. It's 100 plus 100. That's 200 is equal to c squared. And everybody knows the square root of 200 is obviously, 14.14. That's cute. So 14.1. So that's that one, 14.1. Find the angle EGF. EGF, well, this is a 90 right here, and it's half of it, so 45. All right, onward. No, okay, so that's this in a nutshell. My guess is if you're doing the advanced stuff, you stopped watching a while ago. So maybe I'll do another video where I talk about simplifying the square root. It's always gonna be this. You find a perfect square that goes into it, you find the biggest one, and it'll split up. So to do, I'll just real quick do this one, square root of 98. So square root of 98, that's 49 times 2. So I can say, I know square root of 49 is 7, so 7 square root of 2 is how that would simplify. Or 7 root 2 is how we read that. Cool. This has been Mr. Canfield's Math Help. Now, I hope it was helpful. If it was, be sure to leave a like or leave a hi, how are you, or a thank you, or let me know what I can do better. All right, bye.